What if I told you that on a warm summer morning in 1908, something exploded over Siberia with 1,000 times the power of the Hiroshima bomb? And we still don't know what it was. No crater, no fragments, no warning, just 80 million trees flattened in seconds, a fireball brighter than the sun, and a shockwave that circled the entire planet. Scientists didn't reach the site for almost 20 years. When they finally did, what they found defied everything they knew about impacts, explosions, and the laws of physics. This is the story of the Tunguska Event, the largest cosmic impact in recorded history, and one of the most baffling mysteries science has ever encountered. June 30th, 1908, 7:14 a.m. Central Siberia. Sergei Semenov was having breakfast at the Vanavara trading post, about 40 miles from what would become Ground Zero. He was facing north, enjoying the warm morning, when suddenly the world changed. Years later, he would describe what happened next. I suddenly saw that directly to the north, over on Kul's Tunguska Road. The sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger, and the entire northern side was covered with fire. The heat was instantaneous, overwhelming. Semenov felt as though his shirt had caught fire. The searing radiation traveled at the speed of light, reaching him before any sound, before any physical force, a silent announcement of the catastrophe unfolding miles away. At that moment, I became so hot that I couldn't bear it, he recalled. I wanted to tear off my shirt and throw it down, but then the sky shut closed, and a strong thump sounded and I was thrown a few meters. I lost my senses for a moment. 40 miles away, and he was knocked unconscious by the blast wave. Closer to the epicenter, the devastation was total. Evenki reindeer herders, the indigenous people of the region, were thrown from their feet, their tents ripped apart by winds that moved faster than hurricanes. Hundreds of their reindeer simply dropped dead where they stood, killed instantly by the heat and pressure. One witness described the incoming object, a body shining very brightly, too bright for the naked eye, with a bluish-white light. The body was in the form of a pipe, cylindrical. It streaked across the morning sky from southeast to northwest, leaving a trail of dust and fire. And then it exploded. The fireball was visible from 500 miles away, windows shattered in villages hundreds of miles distant. The explosion registered on seismographs across Europe, in Germany, Denmark, Croatia, even the United Kingdom. For several nights afterward, something even stranger happened. The skies over Europe glowed with an eerie luminescence. In London, people could read newspapers at midnight without artificial light. The night sky looked like perpetual twilight, lit by some unseen source. Something massive had happened in the Siberian wilderness. But in 1908, Central Siberia was one of the most remote, uninhabited places on Earth, and nobody knew what to make of it. The explosion happened during a turbulent time in Russian history. The Russo-Japanese War had just ended. The 1905 revolution had shaken the Tsarist regime. World War I was on the horizon. Nobody had time to investigate a strange explosion in the middle of nowhere. Local newspapers reported the event, but the stories were vague and contradictory. Some mentioned a meteorite fall near the town of Kansk, a claim that would later prove false. Others dismissed it entirely as exaggeration by superstitious peasants. The indigenous Evenki people knew better. They called the blast site sacred ground, forbidden territory watched over by Agda, their god of thunder. They believed the explosion was divine punishment for tribal disputes. For years, they guarded the area zealously, preventing outsiders from approaching. Meanwhile, in St. Petersburg, one man couldn't let it go. Leonid Kulik was a Russian mineralogist and curator of the meteorite collection at the Academy of Sciences Museum. In 1921, while conducting a survey for the Soviet Academy of Sciences, he began collecting newspaper reports and interviewing locals who remembered the 1908 event. The stories were incredible, consistent, detailed. Kulik became convinced that a massive iron meteorite, possibly the largest in history, had struck Siberia. He envisioned a crater filled with valuable meteoric iron that could be salvaged for Soviet industry. It was the perfect pitch to get funding. In 1921, he led his first expedition, but the Siberian wilderness defeated him. Traveling by train, horse, and sled, his team managed to interview witnesses and determine the general location of the blast, but they couldn't reach the epicenter before winter set in. Kulik was undeterred. He spent the next 6 years planning his return, gathering more testimonies, studying maps, convincing skeptical colleagues that something extraordinary waited in the taiga. Finally, in March 1927, 19 years after the explosion, Kulik got his chance. The journey was brutal. Kulik and his team traveled by train to the closest town, then by horse and reindeer sled through frozen swampland and dense forest. Local Evenki hunters guided them, though they were clearly uneasy about approaching the sacred site. The window for exploration was narrow. Too early in the year and the snow would be impassable. Too late, and the permafrost would melt into mosquito-infested swamp. As they traveled north from Vanavara, something began to change in the landscape. Trees started appearing wrong, broken, charred, all pointing in the same direction, away from some central point ahead of them. And then they reached it. Kulik would later write, "I still cannot sort out my chaotic impressions of this excursion. From our observation point, no sign of forest can be seen, for everything has been devastated and burned. One has an uncanny feeling when one sees thick giant trees snapped across like twigs, and their tops hurled many meters away to the south. The destruction extended in all directions as far as the eye could see. 80 million trees, covering 830 square miles of forest, had been flattened in a perfect radial pattern. The trees lay like matchsticks, their tops all pointing away from the center. But here's what truly baffled Kulik. At the epicenter itself, he found what he called a telegraph pole forest. Dead trees still standing upright, but stripped completely of their branches and bark. They looked like charred poles sticking up from the ground. This was the exact same phenomenon that would later be observed at Hiroshima after the atomic bomb in 1945. Trees directly beneath a massive aerial explosion remain standing because the force comes straight down, snapping branches but not toppling the trunks. Kulik, of course, didn't know that yet. Nobody did. Nuclear weapons wouldn't exist for another 18 years. And then came the most shocking discovery of all. There was no crater. Kulik searched everywhere. For 3 expeditions over the next decade, he combed the blast site looking for evidence of a meteorite impact. He found several small bogs that looked like they might be craters. He spent enormous effort draining one of them, dubbed Suslow's crater, hoping to find meteorite fragments at the bottom. Instead, he found an old tree stump. The bog had existed before 1908. He took aerial photographs from hired planes, expensive, cutting-edge technology in the 1930s. The images showed the butterfly-shaped pattern of destruction in incredible detail, but no impact site. He collected soil samples, analyzed tree rings, measured magnetic anomalies. He found tiny metallic spherules, microscopic particles of iron and nickel, that suggested extraterrestrial origin. But no large fragments, no meteoric iron to salvage. Every clue pointed to a massive cosmic object entering Earth's atmosphere. But if it had hit the ground, where was the crater? Where were the fragments? Kulik died in 1942 during World War II, still believing he had somehow missed the crater. He never accepted what the evidence was actually telling him. The truth was far stranger than he imagined. The object never hit the ground at all. It exploded in mid-air. In the decades after Kulik's expeditions, scientists began to understand what had really happened at Tunguska. The object, likely a stony asteroid about 50-60 meters wide, entered Earth's atmosphere traveling at approximately 27 kilometers per second. That's Mach 80 times the speed of sound. At that velocity, the air in front of the asteroid compressed so violently that it heated to thousands of degrees. The pressure and temperature became so extreme that the asteroid essentially exploded from the inside out. At an altitude of 5 to 10 kilometers above the forest, the entire object disintegrated in a fraction of a second, releasing energy equivalent to 10 to 15 megatons of TNT. For comparison, that's 1,000 times more powerful than the Hiroshima bomb. It's roughly equal to the largest thermonuclear weapons ever tested. The fireball radiated intense heat downward, igniting trees over 100 square kilometers. But the following blast wave, a wall of compressed air moving outward at supersonic speed, extinguished the fires almost immediately, leaving only charred trunks. The downward force of the explosion snapped trees at the epicenter, but left them standing. Further out, The horizontal component of the blast wave knocked down 80 million trees in a radial pattern, all pointing away from ground zero. Because the object exploded at altitude, it vaporized completely. What little remained fell as microscopic dust, those tiny metallic spherules Kulik found, each less than a millimeter across. This explained everything Kulik had observed, but couldn't understand. But here's what makes Tunguska truly terrifying. This type of event happens regularly. On February 15, 2013, exactly 105 years after Tunguska, it happened again. The meteor, about 20 meters wide, entered Earth's atmosphere over Chelyabinsk, Russia. It exploded at an altitude of 30 kilometers, with the force of 500 kilotons of TNT, about 30 times the power of the Hiroshima bomb. The shockwave shattered windows across the city. Over 1,000 people were injured, mostly from flying glass. If it had been larger, if it had exploded at lower altitude, if it had hit a populated area. The Chelyabinsk meteor was smaller than Tunguska, much smaller. Scientists now estimate that Tunguska-sized impacts occur on average once every 201,000 years. That sounds reassuring until you realize it means there's roughly a 10–50% chance of another Tunguska event happening in our lifetimes, and we have no way to predict them. The asteroid that caused Tunguska came from the direction of the sun. No telescope on Earth could have seen it coming. Even today, with all our technology, objects approaching from that angle are virtually invisible until impact. NASA's Planetary Defense Coordination Office now tracks near-Earth objects and is developing technology to deflect dangerous asteroids. The DART mission in 2022 successfully demonstrated that we can change an asteroid's trajectory, but we can only deflect objects we see coming, and Tunguska proved that cosmic impacts don't announce themselves politely. Consider this. If Tunguska had occurred just 4 hours and 47 minutes later, due to Earth's rotation, it would have exploded over St. Petersburg, then the capital of Russia, with a population of nearly 2 million people. The death toll would have been catastrophic beyond measure. London is 607 square miles. The Tunguska blast flattened 830 square miles. If it had happened over any major city, that city would simply cease to exist, and we would have no warning. 117 years later, the Tunguska site is still being studied. Scientists continue to analyze soil samples, tree rings, and magnetic anomalies. Tourism groups lead expeditions to the blast zone, where charred tree trunks still lie scattered across the forest floor. In Vanavara, the closest town to the epicenter, there's a small museum dedicated to the event. Photos of Kulik's expeditions line the walls. Models show the incoming fireball. Artifacts from the blast site sit in glass cases. But some questions will never be answered. Was it an asteroid or a comet? The evidence leans toward asteroid, but we'll never know for certain. How many people actually died? Official records say up to 3, based on unconfirmed reports. But the Evenki were nomadic reindeer herders who lived scattered across the taiga. How many were closer to the epicenter? How many bodies were never found, never counted, never recorded? What triggered those strange glowing skies across Europe for days after the explosion? The leading theory suggests ice crystals from a vaporized comet, reflecting sunlight at high altitudes. But that doesn't fully explain why the phenomenon was so widespread or so bright. And here's the question that haunts researchers most. What would have happened if it had hit? Because Tunguska was an airburst, an atmospheric explosion. The asteroid never reached the ground. It disintegrated miles above the surface. But what if it had been more dense? What if it had been iron instead of stone? What if it had exploded at lower altitude? The impact would have created a crater kilometers wide. The devastation would have been orders of magnitude worse. Tunguska got lucky. It exploded over one of the most remote, uninhabited places on Earth. Almost nobody died. The trees grew back. Next time, we might not be so lucky. Every night, objects enter Earth's atmosphere. Most burn up harmlessly. But every few years, one is large enough to cause damage. Every few centuries, one is large enough to level a city. The universe is not empty. Space is filled with debris. Asteroids, comets, fragments of ancient collisions billions of years old. Most of it will never come near us, but some of it will. Tunguska proved that cosmic impacts aren't ancient history. They're not extinction-level events from the age of dinosaurs. They're real, they're ongoing. They happen and they can happen again. Somewhere right now, an asteroid is orbiting the sun. It's been drifting through space for billions of years, following its predetermined path through the solar system. And its path might intersect with ours. We won't see it coming. We won't have time to evacuate. One morning, someone will be having breakfast. They'll be looking out their window at a clear, beautiful sky. And then suddenly they'll see the sky split in two. Fire will appear high and wide over the horizon. The heat will be unbearable, and then